Hello and welcome to a video about statistics for engineers. As we know, factory production will create defects occasionally due to various circumstances, which then begs the question, how many of these defects are perfectly acceptable for production? There are several things to consider when thinking about this, such as the significance level, the rate of the factory producing defects, and the size of the sample that we are checking. All of these are essential information to decide the method of approximation for our calculations. We also need to decide on the type of distribution to use. We have several options, such as the normal distribution, binomial distribution, and the Poisson distribution. All the items that have been mentioned are very case-specific. To further explain this, let's check our case study. We want to determine the acceptable amount of defects in a factory production with a 97% success rate, which also equals a 3% failure rate, a sample size of 500, and a significance level of 5%. To start with this problem, we need to derive two hypotheses that go against each other, called the null hypothesis and the alternative hypothesis. The null hypothesis is the item we are checking to be true, which in this case is the probability of producing defects, hence P equals 3% or 0.03. The alternative hypothesis is the antithesis of null, where we argue P is bigger than 3% or more than 0.03. Now that we have information about our study, we can decide on the distribution to use. Since there are only two possibilities of the production, which is either being defective or non-defective, we can go ahead and use binomial distributions. Looking back at the things to consider, we now have all the information we need. Now on to the calculations. Since we are using binary, the formula is xcy times p to the power of y times q to the power of x minus y. X and y is the sample size and the number of defective items respectively. P is the probability of an item being defective, while Q is the probability of the produced item being non-defective. We start the approximation by calculating the probability of there having no defects, and will continue doing this until we reach the probability of there having 22 defects in the sample. Why do we stop here? I'll explain in a bit. Recall that we have a significance level of 5%. To check when we exceed the significance level, we need to calculate the successive probabilities by adding them together one by one. As we go, we look for the value where we end up just slightly lower than 0.05, which is the significance level. We will reach the value of 0.0305 upon checking probability P bigger than 0.046. Now, what do these numbers mean? First, I need to remind you we are looking for the boundary, which is the limit of proportion of defective items to the total items before it becomes significant enough to stop production. We check for the point that just drops below 0.05. The result? This point here. Now P more than 0.046 corresponds to value X of 22. This means that if there are 22 defective products out of a sample of 500, that number is significant, therefore warranting a closing down of factory operations. For conclusion, 3% of defects are acceptable. This is a pretty accurate estimation. However, accurate estimations are still estimations and will therefore contain errors. It is therefore recommended that a mechanism with the technology to detect and analyze defects will be more accurate than approximations. That's all from us. We hope you enjoyed watching this video. Thank you.